All right, everybody. I'm going to do a real quick video today. So this is the fourth in our series of how to use the workbook videos. I'll be using test 3 workbook, and this is the 1P, the one it seems to always open selected on. So that's what we're doing today. Let me zoom out of that. There we are. Yeah, and the problem we're going to be asking questions about is this number 35 right here, deer ticks. So, deer ticks, there it is. Okay, so we have, what do we have here? 153 deer, and 32 of them are carrying ticks that test positive for Lyme's disease. And we want to create a 95 or 90% confidence interval. Okay, I want to be 90% confident, hit enter there. So we'll talk about these a little bit more later, but alpha is like the opposite of your confidence, right? Then alpha over 2 is, and 1 minus alpha over 2, this corresponds to 5% above, or sorry, 5% below and 95% below, we could say. Okay. And there's our z-score that traps 90% of the data. All right. So our measured p-hat, I'll have to enter this as an equals. It'll have to be an equals 32, right? That's how many we found, divided by 153. Boomy boomo. All right. And 153 was my sample size. And bango, bango, we're done. So all that calculation we did in class is good to know about. It's good to understand what's going on with it, right? But when we put our heads down and compute, here is the, whoops. Oh. Don't double click in those. That's bad, apparently. Okay, so we are 90% confident that the true proportion lies between these two values. Yep. Alrighty, so we created a 90% confidence interval. That's what this is here, right? That is the confidence interval. This is an interval. We're 90% confident about it. Okay, so if they want to cut the margin of error in half, what do they got to do? They got to multiply n by 4. Because that's the rule of thumb, right? Or because of the equation we saw in class. Or because the desired margin of error is 0.05408. So looking at this number right here, divide that by 2, right? And the desired confidence is still 90%. And the given p-hat is still equals 32 divided by 153. Okay, so we need an n of 613 to achieve this new margin of error. And the max n, before we start, why is it giving n max? N max. Anyway, here's the n you need. You need one more than that. You need 613. And that's the size of it. Note here that if I give you margin of error, n, and p-hat, you can compute the other stuff, right? And you can compute the desired confidence, or the confidence that was used. There's that. There's that. I think what they're saying here is that we'd be getting into 10 and 10 messiness if our sample got bigger than that, our p-hat got bigger, yada yada yada. I will reference this in class, I think. This is the number we care about, the blue guy. So what did we do? We entered our desired confidence. We entered our p-hat as an equals, x divided by n. We entered our n. We wrote down our answer. And then we said sample size. I want to have this number divided by 2 here. Still want to be 90% confident. And it says that our sample size, our n, would have had to be 612 for that. Yep. All right, homies. Yes, so this is the n calculated for if p-hat was 0.5, just like it says up here. I don't know how useful that is. I'm sure it has a use somewhere, but this is the number I care about, folks. Okay, not to whip a dead horse. There's a nice clean example: sample size consideration, confidence interval calculation. I'm gonna call it good, y'all.